All right, y'all. So this lesson's on two things today. So we're going to talk about radical functions and absolute value functions. And just kind of a recap, anything that is a radical function, radical means it's going to have this symbol, right? So often, and you'll even hear me say it, I say square root, but we could have a cubed root radical function, right? And then our absolute value functions are the absolute value bars that look like this, and this is when we have a negative number that's in the inside, and we would say we would have a positive number. And all absolute value is doing is it's telling you the distance from 0. So that's why that number is always positive. It's not just we take what's in the inside and make it positive. What we're doing with absolute values is asking what's the absolute distance from 0. We don't care if it's positive or negative, okay? So we're going to start with radical functions, and let me give you the steps here, and then we'll work through one. So step 1 is you have to isolate the radical term. So what this means is it has to be all by itself. So isolate means all by itself. So if I look down here, this is not isolated. I have an x over here, and I have a 1/2. This is not isolated. I have a +1 here. This is isolated. All I have is a radical here, and all I have is a radical here, okay? Now this one is as isolated as it can be because I have this 2, and even if I move the 2 over here, it's still going to be on the outside of the radical. So we're going to treat these a little different, but if we have the opportunity to make it just a radical, we have to do that first, okay? So step 2, when we do this, is to square both sides. So if this is my radical, we never write this, but we have, this is the radical, right? It's this implied little 2. And so when we square this value, we get what's on the inside. So for example, if I have the square root of x, and I square the square root of x, this is like saying I have x to the 1/2. So when it's squared, it's to the 1/2. And when I square this, I end up with just x, okay? So what happens is when we square that radical, we're actually just eliminating it, and we end up with just whatever is on the inside of that, okay? Then the next thing that we do is we're going to solve for the variable. And then the last thing, which is one of the most important things with radical and absolute value functions, that's why these are connected here, is we're going to check for extraneous solutions. Big word. In fact, it's so important, that's what this whole box is saying right here, extraneous solutions. So what it says is an extraneous solution occurs when you solve an equation and you get a solution algebraically. You get a solution. But when you check your answer in the original equation, the solution doesn't work. So if your solutions, you plug them back in to check your work, that's what we're doing here, check your answer. All of your solutions are extraneous, you have no solution. Okay? All right, so let's practice this a little bit, see what we come up with. So step number 1, isolate the variable. And as we isolate the variable, you're going to do the same thing that you would do if you were just going to solve this without a radical. You're using your reverse order of operation order. So I'm going to subtract 8 from both sides. So 1/2 square root of x equals -3. Hopefully you see this. You're going to multiply by the reciprocal. We're not dividing by 1/2. We multiply both sides by the reciprocal. That makes this side go away, and I end up with square root of x equals -6. So at this point, I'm going to say I think we're going to have an issue, but I'm going to keep going. I put a little asterisk there because I'm going to come back to that in a second. All right, but if I go up here, I'm going to square both sides. So if I square both sides, that means I'm squaring this one and I'm squaring this one, so I end up with x equals 36. So x equals 36 is my solution algebraically, but I have to test it. So what I'm going to do is I'm going to take this number and I'm going to plug this number 36 right here. I'm going to plug this back into my original. So I would have 1/2 square root of 36 plus 8 equals 5. And what we're looking for is we're solving to make sure that this is true. So square root of 36 is 6. So I would have 6 divided by 2, which is this 1/2, plus 8. So this is 3 plus 8. And all of these, of course, equals 5. And this tells me 11 equals 5. And this is false. This is not true. 11 does not equal 5. So here, this is no solution. All right, so let's talk about this. If we have an extraneous solution, it says you're going to solve it. You're going to get an answer. I got an answer. X equals 36. But when I go in and check my answer, this is not true. It's false. So I have no solution. Now, if you remember this little pink asterisk up here, so I had the square root of square root of x equals -6. If you remember up there, I said, I see a problem. And here's the problem. I could have stopped right here. And I could have stopped because there's no value where I take a square root of anything that's going to give me a -6, right? If I take a square root of 36, I'm going to get a +6. So there's no solution that makes this happen. So clear back here at this step, I could have said no solution. All right, let's do another one. I have to isolate the variable, or isolate the radical. So I have to move the 1. So I end up with 3x minus 8 equals 2. So now I'm going to square both sides. So I'm going to square this side and I'm going to square this side. Now, I know there's a bunch of garbage underneath the radical here, but that's okay. Because I'm squaring a radical and everything is underneath, I just get to remove the radical. I'm done on the left side. And then the right side becomes 4. Okay, so now I solve for x. So 3x equals 12 and x equals 4. So I have this value, x equals 4, and I'm going to take it. I have to go back up here and plug it in and check it. So I would have the square root of 12 minus 8. So this 12 is 3 times 4 plus 1. So the square root of 4 plus 1. So this is 2 plus 1, which is 3. And I'm looking for this to equal 3. So that's true. So my answer here is x equals 4. Okay, now, because I'm only solving for x, I'm not going to have this ordered pair. It's going to be like everything else that I had, where I'm just going to have these values of x equals. All right, so this one looks a little bit harder, but it's actually easier. So this is isolated, and this is isolated. So I'm going to square this side, and I'm going to square this side. And when that happens, all of those radicals go away, and I just have what's underneath the radical. So I would have 2x minus 1 and 5x. So if I move this around, I would have -1 equals 3x. And then I would divide, and I would have x equals -1/3. Okay, so now I need to go up here and test that. So I would have 2 times -1/3 minus 1, right? I'm doing the left side first. So this becomes -2/3 minus 1. Well, this value here is going to be 3/3, which is a negative number. So this would give me -5/3. Now on the right side, and this is the square root of this, on the right side, I'm going to have 5 times -1/3. So I would have the square root of -5/3. So the question, this is a tricky question. The question says this is -5/3 and this is -5/3. But the question is, can I have a negative under the square root even when both sides are positive? And the answer to that is no, I can't. So when I go back to this part, even though I have an answer, this is going to be no solution again. Okay, now This one looks a little bit different. So now I have a 2 value that's in the front. But I can't isolate it because if I divide both sides by 2, then I still have that 2 value. So what I'm going to do is I'm going to do the same thing. I'm just going to square the whole thing. And we've done exponent rules. So if I square this, I have to square the 4, or the 2 squared. So I would end up with 4x on the left side. The 2 goes to the 2, the 2 goes to the square root of x. On the right side, I would have 2x plus 2. So I move this over, 2x equals 2, and x equals 1. Okay, so now I want to go test it. So on the right side, I would just have 2 square root of 1. I plug the 1 in. On the left side, I would have 2 plus 2, so the square root of 4. And the square root of 4 equals 2. Now, these two things look different, but they're the same, because the square root of 1 is 1. So this is the same as 2 equals 2. So that's true. Okay, we go down here. This looks very similar to what we had on number 4. So I'm going to square this side, and I'm going to square this side. So on the left-hand side, the 4x is going to stay the same, right? That just gets dropped. But this 1/2 gets squared. So this is the same as saying 1/2 times 1/2, which is 1/4. So I'm going to have the 4 in the denominator. And then on the right side, I have 2x minus 2. So this cancels because I reduce. And I would have x equals 2x minus 2. So if I move things around, I end up with x equals 2. So we want to test this now. So on this side, I would have 1/2 times the square root of 8. And on the other side, I would have the square root of 4 minus 2 is 2. So you look at that and you're like, uh-oh, those aren't the same. It doesn't work. But the square root of 8 can be reduced. So we know that the square root of 8 is the same as 4 and 2. Right? So when I reduce just the radical, I get 2 square root of 2 over 2. Right? So 2 square root of 2, this guy becomes my numerator. This 2 goes here in the denominator. And this equals the square root of 2. These two things reduce, and we have square root of 2 equals the square root of 2. So I do have an answer, x equals 2. Okay, so number 6. Number 6 is as tricky as it gets when we're dealing with radicals. And it's because I have this plus 2 over here. So when I had this as a coefficient, and I distribute this through, we say that this is squared, and it's because it's 4. Same thing over here. Now this one's different because if you remember, we did this when we had our exponent rules. Because I have this addition in the middle, I can't distribute it to both. So what this is saying, if I square both of these, this is saying I have to FOIL it. So I have the square root of 3x plus 2 times the square root of 3x plus 2. And then on the left side, there's nothing outside the radical, so I just drop the radical bars. So on the left, that's going to stay the same, but on the right, I have to FOIL it. So I have 3x times 3x. As I multiply these two things together, the radical drops, so it becomes just 3x. And then I distribute to the far end, so plus 2 square root of 3x. Then I go to the inside, 2 square root of 3x. And then I go to the outside, plus 4. So when I do the math here, what you see is that I still have a radical, right? I still have this middle term right here. So I'm going to move everything around and see what I have. So if I subtract 3x from this side, subtract from the 3x from this side, it goes away. If I subtract 4 from this side, I end up with 12 over here. Okay, I'm going to do one more thing. I'm going to divide this by 4. and I get the square root of 3x equals 3. Okay, so now what I have is a standard radical expression. So I had to go through it one time, and now I have to do it again. So I'm going to square this side, I'm going to square this side, and I get 3x equals 9, so x equals 3. Now, I need to plug it back in here. So 3 times 3 is 9. 9 times 16 is 25. So this becomes the square root of 25, which equals 5. Over here, I plug it in, and this gives me the square root of 9 plus 2. And the square root of 9 is 3. 3 plus 2 is also 5. So x equals 3 is my solution. Okay? All right, let's flip this over. We've got 2 more radical equations here. So let's do both of these. This one looks exactly like it did on the other side. So I'm going to pause the video, and I'm going to have you work this one. Let me give you a hint here before you do the math. This side, everything is squared, so I'm going to drop. This side, I have a plus operation in there that's outside the radical, so I have to FOIL. So go ahead and try that and then come back. Okay. When I FOILed this out here, I dropped parentheses, FOILed this middle term, combined like terms, and then I stopped at this point. Because I have this isolated radical, there's nothing I can do that's ever going to give me a negative 2. Now, you might have gone forward, kept going, but you didn't need to. You could have stopped at this point. Okay, last one. So I square this side, I square this side. Hopefully you see that this minus 4 is outside the radical, so I'm going to FOIL again. So x minus 16 on the left. And then this is an easy one to FOIL. So if I rewrite this, because there's no coefficients here, this goes away. So it's x minus 8 square root of x plus 16. Okay? So now x goes away with the x. The negative 16 moves over. So I'm going to rewrite this. Negative 8 square root of x equals negative 32. Now over here we said, okay, I'm going to stop because there's no number that's going to give me a negative 2, but my radical's not isolated. So if I divide this by negative 8, and I divide this side by negative 8, now I have a negative divided by a negative. So I get the square root of x equals 4. Right? Negative divided by a negative is a positive number. So now I can square both sides, and I get x equals 16. Now, when we check this, if I put 16 over here, I get 16 minus 16. So 16 minus 16 is 0. And if I go over here, I have the square root of 16, which is 4. 4 minus 4 is 0. 0 equals 0 is true, so that is my solution. Okay? All right, this video is getting kind of long, so I'm going to stop this and make this part 1, and then I'll do another one for absolute value equations.